Hello friends, myself R.D. Mahajan presenting my video on numerical integration. First point, trapezoidal rule. First of all, I will discuss what is by numerical integration. Evaluating integration of f of x with respect to x between the limits a to b when that f of x is expressed in terms of tabulated values, then that process is called as numerical integration. For that, see the figure. Uh, in figure, we have curve y equal to f of x expressed in terms of the tabulated values. Values of x are x0, x1, x2, x3 up to xn, and the corresponding values of y are y0, y1, y2, y3 and yn, where the lower limit is a, that we call as x0, and the upper limit is b, we call it as xn. Then we divide that interval into n number of equal intervals. Therefore, x1 is x0 plus h, equispace or equidistance. Distance between two successive values is h. X2 is equal to x1 plus h, x3 is x2 plus h, x4 is x3 plus h, like this. Last one, xn is equal to xn minus 1 plus h. Therefore, in this manner, we can divide that interval into n number of intervals, which I have shown in this figure. On x-axis, the values of x, on y-axis, values of y. Difference between two successive values is h. Distance between x0 to x1 is h. Distance between x1 to x2 is h, like this. Then we know the meaning of this integration, definite integral. Integration of y with respect to x between the limits a to b. Its geometrical meaning is sum of the area under that curve between a to b. That is the meaning of definite integral. Therefore, here with the help of that concept, I try to explain how we can obtain that trapezoidal rule. Trapezoidal rule for numerical integration. It is stated like this: integration of y with respect to x between limits x0 to xn is given by h by 2 y0 plus yn, sum of these two values y0 and yn, plus 2 times remaining values, that is y1, y2, y3 and so on. Last one is yn minus 1. Whatever this formula I have written is called as trapezoidal rule. Then, to explain that trapezoidal rule, already I stated that we have to divide this interval into n number of equal intervals. Therefore, we have the first step between x0 to x1. We try to find out the area under that curve between x0 to x1. That is nothing but the area of this first trapezium. This is the area of that first trapezium. Then we find out the area of the second trapezium between x1 to x2. Then we find the area of the third trapezium, then fourth, then fifth, like that. We find the area of that n trapezium. And then if we take a sum of that all areas, nothing but this value of that definite integral by trapezoidal rule. It is the sum of the areas under the curve between x0 to xn, and by that trapezoidal rule, it is equal to this sum of the areas of n trapezium. Therefore, this is the first trapezium. We find the area under that trapezium. Then second trapezium, we find the area of that trapezium. Then area of the third, area of fourth, area of fifth, like this up to nth trapezium. Therefore, it is the sum of the areas of n trapezium, and that is given by this formula. Integration of y dx between x0 to xn. Once again, I will repeat that formula. It is h by 2 y0 plus yn plus 2 times remaining values y1 plus y2 plus y3 plus so on yn minus 1. Therefore, this is called as trapezoidal rule. Then I will discuss one simple problem, how we can apply this trapezoidal rule to evaluate the definite integral. Evaluate integration of x square with respect to x between limits 0 to 1 by considering 5 equal subintervals by trapezoidal rule. And therefore, we first find the value of h. H as b minus a upon n. The value of b is 1, a is 0, lower limit. Number of steps 5. Therefore, that value of h is 0.2. Then we make a table. First value of x is 0, a difference of 0.2. Therefore, next one is 0.2, 0.2 plus 0.2, 0.4, next 0.6, next 0.8, and the last one is 1. And then corresponding values of y, 0 square is 0, 0.2 square is 0.04, 0.4 square is 0.16, 0.6 square is 0.36, 0.8 square is 0.64, and 1 square is 1. And for easy calculation, we mentioned that first one is as x0, next one as x1, x2, x3, x4 and x5. And the corresponding values of y are y0, y1, y2, y3, y4 and y5. And then by trapezoidal rule, first we find h. Already I have calculated the value of h as 0.2. Then by trapezoidal rule, it is integration of y with respect to x between limits a to b is equal to h by 2. Here y0 plus last value y5 plus 2 times remaining values. Remaining values are y1, y2, y3 and y4. Therefore, this is the trapezoidal rule. And then we substitute the corresponding values. Therefore, integration of x square with respect to x between limit 0 to 1. And after obtaining the value, we compare with the exact value of this integration. Here h is 0.2 divided by 2. Y0 plus y5, 0 plus 1 plus 2 times remaining values. Remaining values are y1 0.04 plus y2 0.16, next y3 0.36 and last 0.64. And then simplifying it by calculator, we get that value. It is 0.2 divided by 2, we get 0.1. 0 plus 1, we get 1 plus 2 times sum of all these values, 0.04 plus 0.16 plus 0.36 plus 0.64, that value is 2.4. Then addition of this, we get 0.1 multiplied by 1 plus 2.4, we get 3.4, and therefore into 0.34 as the value of that integration between limit 0 to 1 by trapezoidal rule. Okay, here I obtain the value of that integral by applying this trapezoidal rule. We get the value as 0.34. Then we compare this with the exact value. Exact value means we perform its integration directly and substitute the upper and lower limit to get the exact value. And therefore, that I will perform here. It is integration of x square with respect to x between limit 0 to 1. Integration of x square is x cubed by 3. Limit from 0 to 1. 1 by 3 outside constant as it is. And then upper limit minus lower limit. Upper limit is 1, lower limit is 0. And therefore we get that value as 1 by 3. And 1 by 3 calculator, it is 0.33. Therefore, exact value is 0.33 and approximate value by trapezoidal rule, it is 0.34, a difference of 0.01. Therefore, whatever the value we have is the correct one. It is somewhat nearest to 0.33. One more I will discuss in my next video. If you like my videos, please share it as well as subscribe to my channel to get notification for my new videos. Thank you. Thank you for watching.